So let's get right to it. Right off the bat, I'm happy to talk about our Super Bowl of astronomy. As you can see, there's our very own Tony Cook Zebra Centaur. We've set up a five-way battle between five different teams: the dark matter and gravity team, the Galaxy and Quasars team, the modern Milky Way, stars and nebulae, and lastly, exoplanets and brown dwarfs, which you gotta love the Galileo replica telescope we added there. So we divided up all the big announcements from the AAS meeting into those teams, and we're going to award points based on the discoveries. And then we'll tally up all those points, get to a subtotal, and then we'll open it up to you to vote in our fan favorite poll. And then next month, we'll tally up all the points and we'll award the golden Griffies. Are you confused? Well, here's Bill to tell you all about it.
Ladies and gentlemen, girls and boys, science lovers around the globe, the 237th meeting of the American Astronomical Society has completed, and have we got some space news for you. This meeting is called by some, and I quote, the Super Bowl of astronomy. We've got globular clusters, exoplanets, quasars, magnetars. We've even got a triple galaxy collision. Wow! This Friday, February 5th, at All Space Considered, we'll tally up the points for each scientific touchdown, home run, three-pointer, hole-in-one, strike, spare, or wicket, and set the stage for you to vote and pick the final fan favorites. It's astronomical playoff season where you pick the winners. Excited? Confused? We're not surprised. We'll mix every metaphor we can find. After all, why would we want to stick to just one metaphor? So this month, root for your team in the AAS Super Bowl. Hear the latest Griffy buzz, and then in March, join us on the virtual red carpet to see the stars, the real stars, in the annual All Space Considered Golden Griffies. We kick it all off this Friday on February 5th, live at All Space Considered. Thank you.
That's right. That's now. We're kicking it all off live. So we have our scoreboard in place, as you can see here, Griffith Observatory, the American Astronomical Society Super Bowl, and we welcome you to Griffith Park. First of all, we've got zeros across the board. So let's take a look at some of our scores. So first, news from the dark side. Dark matter and gravity team is up on our first day in the first inning. Globular clusters, which are large clusters of stars, hundreds of thousands to millions of them at a time, can be used to trace the dark matter in galaxies. And it turns out some of the most dwarf-like don't have very much dark matter. They scored 3 points for that result. Another result here, you can go in and use pulsars to measure the Milky Way's gravitational field. An incredible 3-point result. We gave them a field goal for that one as well. Next one. All right, around the Earth, you can search for the gravitational wave background. We've all heard about colliding black holes, colliding pulsars, making gravitational waves. Well, there's just a background constant hum due to the ones that are sort of close, really long wavelength radiation. We gave them 6 points for this because they actually picked up a signal. They don't know what the signal is, but they picked one up, so they got a touchdown without the extra point. Moving along, this confusing result, this was the best I could show for you. There was not an easy picture. It seemed somewhat important because the galactic center has emission coming out of there that we don't fully understand what it is. And they went in and made models of it, but only 1 point because it wasn't easily explainable to the public, and yet it was a press release. So if you really love this one, maybe you'll give it some fan favorite points. So tallying up the points for the dark matter team, gravity team, 13 points in our first inning. Moving along into our next inning, there was a triple star system found in the Kepler survey. So a very interesting survey. It was a confirmation of the second planet Kepler ever saw. It's in a triple star system. So they got 3 points for confirming that exoplanet finally. Another exoplanet result. It's the first result of a giant planet transiting in the outer part of a solar system. So now it's 200 and some days it takes to orbit. I forget the exact number, but since it's the first big one they found that isn't super close to its star, we gave them 3 points for that. A 2-point result for a rocky planet around a 10 billion year old star. So a very, very old rocky planet. We gave them 2 points. That's a safety. Maybe it's a 2-point basket, though. I don't know which. We need to think about this because this one's a 3-pointer. There was a sub-Neptune that can be turned into a super-Earth. The idea of this is sub-Neptunes are planets that are like Neptune, but smaller. Sub-Neptune, go figure. If they're close to their star, that intense radiation over billions of years can blow away that atmosphere, leaving behind a super-Earth. Now, is it going to look like Earth like they did in this picture? Probably not, but nonetheless, they got a 3-point bucket for that one. tallying up the points for our exoplanet and brown dwarf team down at the bottom, the very bottom row. They got 11 points total in the second inning. Moving on to our third inning, 1 point for the Galaxy and Quasar team, where they saw a periodic nuclear transit. So there's a periodic transit going on, a signal that comes and goes, but it's periodic, that they can see coming from the AGN down near the center of the black hole there. They got 1 point for that result because there are a lot of AGN. This result was seen by a team of citizen scientists, in fact, young ones, that saw the brightest galaxy in the redshift 5 range. And it's this arc you're seeing that looks like sort of a one-eyed smiley face. And they got a 2-point bucket for that one. Now, this is a X-ray source that doesn't give off much optical light at all. It's a heavily obscured quasar, and we gave them a 2-point score for that one. Lastly, the most distant quasar in the universe. Now, this quasar is when the universe was only 600 and some odd million years old. So very, very early. The black hole is so big that makes this literally millions of solar masses, that how do you make them that big this early on? It actually confounds formation models a little bit. So we gave them 5 points for this. That's like an ace in tennis. So they get a five love going on out of that one. So mixing our metaphors here, we'll continue tallying up all the points for galaxies and quasars. They got a massive 10 points. So you might wonder about that 10 versus 13, 11. Don't worry, that was only the first galaxy session. They've got more points coming their way. Moving along into our next inning, we have an interesting story about symbiotic stars in the Apogee survey. So this is a white dwarf that's pulling material off of a red dwarf for 2 points. We have another interesting story about new members in a stellar stream around the Milky Way. There are lots of streams. There are dwarf galaxies being torn apart by the gravity of the Milky Way. Well, this is a new stream that they're finding more stars for it, so they get a 3-point bucket. We awarded a 2-point basket for these folks that used the Galaxy Zoo 3D platform or citizen science crowdsourcing features in galaxies. And you can see in this galaxy, they identified the bar across the center of it. They identified some stars, and they're able to go in and automate a lot of the way you can determine what these shapes are and what these galaxies look like by having citizens go in and do it. So a 2-point bucket for everybody's efforts on that. Now, lastly, 2020, what a year. We are on Sky and taking data. What the heck are we talking about there? Well, it's the Sloan Digital Sky Survey 4 opening up to the Sloan Digital Sky Survey 5. It's one of the longest running sky surveys, covers the whole sky, and they made a couple of discoveries that they just show you on this. There's more discoveries than 2, obviously, but I gave them 1 point for the Quasars and Galaxy team and 1 point for the White Dwarf team, and moved on from there, the Stars team, because there's so many discoveries in the Sloan Digital Sky Survey. Like they like to say, it's the Energizer Bunny of sky surveys. It just keeps on going. It's been going forever. We tally up all those points, and as you can see, we awarded 3 to Galaxies and Quasars, 3 to the modern Milky Way, and 3 to stars and nebulae in that inning. So splitting the points up in inning 4, getting a little more exciting here in our Super Bowl of astronomy. Who's going to move on to the playoff round? That's the big question. Now, bursting magnetars, they were super clever. They decided to talk about this magnetar that's masquerading in the Sculptor galaxy. So they broke their discovery into several different press releases. And the first one just said, hey, we found this thing. 1 point for the find. 1 point for saying, is it a gamma ray bursting or is it a giant flare? We don't know which, but we're working on it, trying to figure it out. And they figured out it's actually a giant flare. So they get a point for proposing it and 3 points for saying it's a giant flare going on, a magnetar flaring. Now, what's neat about this is this flaring magnetar looks just like gamma ray bursts. So they think these mysterious gamma ray bursts that we say, these high energy, in fact, it's making my camera shake with so much energy, coming from distant universe galaxies. So much energy comes from these, we can see them very, very far away. And they believe that one of the sources for these could be bursting magnetars. So we give them 5 points, another tennis score, for coming up with that theory of what these gamma ray bursts are. And fast radio bursts. Actually, no, I take all that back. I've been misspeaking. It's not the gamma ray burst, it's the fast radio bursts that are explained by it. And of course, we've talked about fast radio bursts in the past. Much lower energy events, but they come from very, very far away. I realized I was just misspeaking, saying gamma ray burst instead of fast radio burst. So We've talked about those before. They've been mysterious for a long time. We give them 5 points for determining the source of those fast radio bursts is indeed these magnetar stars that are bursting. And then they wrote up a 1 point, kind of a closing statement where they claimed they've solved the mystery of what these fast radio bursts were. So a total number of points there we award of 8 points to stars and nebulae and 3 points to galaxies and quasars, because that's how the points get divided up here, because it's magnetars bursting. It kind of fit both realms. They're stars, but they're also in distant galaxies. So that's where we gave our points. Moving along into the realm of galaxies and quasars, the second session. Three's a crowd, a triple galaxy collision. Oh, I think I moved along too far. We're in the DESI section. Sorry, the dark energy survey. That's the image I'm seeing here. I was wondering, where did the three galaxies go? You see this galaxy here, dark energy survey has a platform you can go in and they show you all the sources they've observed. They've released their data. So we gave them 3 points for the data release. We gave 3 points for them discovering extremely cold brown dwarfs. Then we gave them, oh no, this is the strong gravitational lens, of course. I have to look at the actual slide of what's up there, of course. You're seeing gravitational lensing arcs around these blue sources. Here are our brown dwarfs around our Earth, 5 points for that discovery, nearby brown dwarfs. And then finally, black holes are everywhere. Now you might guess, again, dark energy survey, we awarded the points spread across our different contestants again. We gave 9 points to the galaxies and quasars, and we gave 5 for those brown dwarfs to the exoplanet and brown dwarf team. So looking at our scores now as we're moving on, we're more than halfway done here with inning 6 finished. Into the 7th inning, we've got our leader, the galaxies and quasars, with an astounding lead of 25 points. The next nearest is our exoplanet and brown dwarfs at 16. Moving right along into our exciting 7th inning. Here's where we finally have, so we can see our triple galaxies there that have merged. Three's a crowd, galaxy collisions, 3 of them colliding. What does that mean? And what does it mean for black hole accretion? We went ahead and awarded some points for that, and I can't quite see what they are, but hey, it'll all make sense when we get there. Moving on to the next slide, if you can advance it for me. Perfect. We have a galaxy here. These are the deep images of mergers. And actually you're seeing there, it flashed back and forth, and that's signs that this galaxy, Centaurus A, has merged with many galaxies over time. And we can move ahead to the next one, and we can take a look here for the magnetic highway, looking at the magnetic fields of M82 and its super wind. So a pretty cool image there. And finally, the magnetic chaos hidden in the Whirlpool galaxy. If we take a look at our next one, you can see the Whirlpool galaxy, famous galaxy, popular among a lot of people because it's so pretty. They've mapped the magnetic field in this galaxy. So let's take a look at what points we gave to these galaxies as we move to our next slide. And we see here, it looks like they've racked up another 11 points for galaxies and quasars for a whopping 36 points. Let's move ahead and see if we can find any more points for any other teams. Well, we have the rise and fall of a remarkable eclipsing binary star. I don't see any binaries there, but we did give them some points. Let's move ahead. The final projected sample for hundreds of thousands of eclipsing binaries should be seen through machine learning. They're predicting when they go into the test sample, they're going to be able to find these through the machines learning what to look for. Finally, moving to the next one, unbinding the stellar envelope in a grazing envelope evolution. What does that even mean? Well, 2 stars are close to one another. They affect one another, and material can be flung out, material can be transferred, and you can get jets. Super cool stuff. Let's move along to the next one. And we can see here, we are finally exploring the supernova remnant connection. So X-rays in this supernova remnant. Very cool. And finally, lastly, in this section, the center of expansion and an age of oxygen-rich supernova remnant. So this was the evolving stars in supernova section. Let's take a look how the scores fell out with these exciting ones. You all have seen the scores I've awarded, but they're too small for me. So what do we have here? It looks like we gave 9 points for stars and nebulae over that section. So they've gone up to 20, getting closer to those galaxies and quasars. Let's move along to our final day, our Friday. And we see here, we have extreme contrast ratio imaging of Sirius. Believe it or not, one of the brightest stars in the sky is dead center in that image, and they've been able to remove it and see the faint stars around it. They can see Sirius B. Very cool technique. Let's move along to the next one. This is the galactic warp of the Milky Way. They were able to go in, and by flipping this image side to side, you can see how the disk of the Milky Way is actually warped. So a pretty neat technique to get some points for that team. Move ahead to the next image. Here we're investigating a new stellar association in the galactic disk called Theia 456. What does it mean? Is it real? Well, vote some points. Maybe you can hear more about it next month if you vote for them in the fan favorite. So let's take a look at our last modern Milky Way section. All stories about our Milky Way. Here's one about the defensive halo blocking an incoming gas cloud. This is a story that, of course, Lord Danley would have been very fond of, gas being added under our galaxy. So what's this story all about? I do wonder. So let's move ahead and see what points we scored for our modern Milky Way. It looks like we awarded 15 points. So the modern Milky Way finally gets 18 points to their score. Let's take a look at our very last 10th inning here. Our last session that was on Friday of the Astronomical Super Bowl. Our first story, scientists explain a jet pointing the wrong way. Now, jets do come out of AGN, out of these black holes as material falls in. Some of it gets accelerated and shot out, usually perpendicular to a disk. This one was pointing the wrong way. Well, why? Maybe vote them some fan points and you might hear about it next month. Let's move on to the next one. This is the Butterfly Nebula. They went in, gorgeous image. They did some analysis of what was there, what chemicals were there, and how it formed. Just gorgeous. So we awarded a 7 points. I remember that one. And finally, we end up our whole AAS of astronomy, the Super Bowl, with the Jewel Bug Nebula, another planetary nebula as these stars shed off their outer layers as a large star dies, a star like the sun. Makes these beautiful things called planetary nebulae. Well, they went in and investigated where the chemicals were, how the outflows happened. Very nice work. So we awarded another 7 points. So let's go to our scoreboard finally, and we'll take a look at our final scores. Our subtotals, we have in the lead Galaxies and Quasars with 37 points, 34 stars and nebulae, just barely behind. That last inning was very exciting, and they scored a few more points. They might have pulled ahead. Then way kind of far behind, we've got the modern Milky Way at 18, and at 16, we've got the exoplanets and brown dwarfs, and way, way back there, dark matter and gravity with only 13 points. Now, you don't like that? You don't want to have Galaxies and Quasars win the golden Griffies? Well, you can change it. You can vote. You can go online. That link right there, it should be in our description of our video. We'll also tweet it later after the show. You can go there, fill out the form, and vote for your favorite. One vote, 1 point. If enough people vote for one of these teams that are behind, you can pull them into the lead, and we'll award them the golden Griffy, and we'll tell you more about those stories. We'll tell some of them in detail, and you'll understand more about what I was just babbling on about for a while.